Hey everybody, I'm going to show you a way to solve this problem that I think is the easiest way to do it based on what else we've been doing in the class. There is another way to look at it, and I have another video that's linked here for that, but I think this is the easiest way to think about it. Of course, you can take a look at both videos and see what you think. So the idea here is that we have this element, palladium 100, and it's got a half-life of 4 days. Now the first thing is, don't let this 100 throw you off. That's the name of the isotope. That's not actually anything that we're going to use in the problem. So just be careful there that you don't take numbers, and use them when you're not supposed to. Again, this is like the whole name of the element in this case. So what we're going to do is first use this information that the half-life of this element is 4 days of this isotope. So we're going to go back and use our equation here so that P of t is P sub 0 of e to the kt power. Again, remember P sub 0 is the initial amount. Now what we want to do is just kind of come up with some initial amount since we're not given one. The half-life doesn't depend on how much you start with, so we can really make this whatever we want. So let's just make this like 1 milligram, and then I know that after 4 days I should have half a milligram. And again, you could kind of do whatever you wanted to right here. You could make this 100 and this be 50. This could be 1,000. This could be 500. The thing is, you're always going to end up dividing by whatever's on this side over here, and you should always end up with 1/2. So it doesn't really matter because you'll always have 1/2 of whatever you have right here. So the easiest thing I think is just to do 1 and 1/2. Now what we're trying to get is we're trying to figure out what this decay value is, this constant right here, k. This is kind of always our first step for these types of problems. So that's what I want to try to solve for first, figuring out what this k value is going to be. So to get that k down from the exponent, I'm just going to take the natural log of both sides. So natural log of 1/2 is equal to natural log. Again, the 1 can kind of go away. I'm just going to write this as e to the 4k instead of k times 4. And then our log rules allow us to drop this 4k down. So end up with natural log of 1/2 is equal to 4k times the natural log of e, which is nice because the natural log of e is just 1. So we just end up with natural log of 1/2 is equal to 4k. So that tells us that k is just going to be the natural log of 1/2 divided by 4. Now you could leave the k as this exact answer. That would actually be a little more accurate, but I think it's going to be okay for us if we just go over here and get a decimal approximation. As long as we go out to maybe like 4 decimal places, I think we should be okay. So do natural log of 1/2 divided by 4. This is a negative number, of course, because it's decaying. So this is going to be negative 0.1733. Let's go to 4 decimal places, and I think we'll be okay. If you wanted to, you can always go out a little more, just to be a little more accurate. Okay, so what we're going to do is now go back into our model, and this is the constant that we're going to use. The thing that makes all of these models different is this constant value, which is different for different elements. But once we have this in here, we should be good to go. All right. Cool. So that's always our first step, and what we're going to do is we're going to use this equation now as our model going forward. Okay, so now let's get to our question. It says, after 14 days, a sample of palladium 100 has been reduced to a mass of 8 milligrams. So what we can say, we don't know the initial amount. That's what we're looking for. So that's going to be an unknown value. Okay, so let's write this in here the same. This amount is unknown, but we know, actually I should erase this here. We know that after 14 days, so I'm going to put 14 right here, that we should end up with 8 milligrams. So I don't know the initial value, but I know that after 14 days, I should have a final value of 8 milligrams. So now I'm just trying to solve for p sub 0 right here. And what's nice about this is that remember that e is just a number, and so when you raise e to a power, that's just one big number. So this is just just some number. So what we can do is I can just take 8, I can just divide both sides by this number here, and then we should have this thing solved for p sub 0. So I'll just go ahead and write it all out just so everybody is clear on what I'm doing. So I'm going to divide both sides by this e to the negative 0.1733 times 14. And then, of course, on the right-hand side, this divides out. And then what I'm left with is going to be the p sub 0. So let's see what this is going to be. So 8 divided by, let's go ahead and put this guy in parentheses, e raised to the negative 0.1733 times 14. And we'll close our parentheses. Oops. What do I got going on here? Oops, oh I see. I forgot to put my decimal point. So let's just type this in again. 8 divided by e to the negative 0.1733. What was happening is I did e to the 1,733 times 14, which is a pretty big number, so it was giving me some trouble there. And this is going to be division. All right, so let's see if that does it for us. Cool. So there we go. So our initial amount here our p sub 0 is going to be approximately 90.5 milligrams, like that. Then the follow-up question is actually pretty easy from here. What is the mass after 6 weeks? So be careful. This is in days. This initial formula down here, T is in days, so we want to make sure that we convert this to 42 days and use that in my equation. The reason that this T is in days is because initially when I set this up I was dealing with days, so you have to be very careful with that. So if I want to figure out how much is there after 6 weeks, that's just going to be P of 42, so 42 days. And I know that I started with 90.5. Again, always check and see how far they want you to round. I just rounded this to half a milligram. I guess if we wanted to, we could even make this 2 decimal places, 90.53. And this is going to be times e to the negative 0.1733. Again, I'm just using my exact same equation, but now I have the p sub 0, and in this case I have a t that I'm going to put in. That's going to be 42. And then I should get an approximation here for this answer. So let's go over the calculator. So this would be 90.53 times e raised to the negative 0.1733 times 42. And let's see what we get. So this is going to be approximately 0.0625 milligrams left over after 42 days.